Hi, my name is Garn, and I'm going to talk about my ultrasonic distance measuring gun. First, I should explain what the gun does. It's a gun that measures the distance between you and what you point the gun at. When pressing the first button, it would display the distance in centimeters. When holding the other button, it will convert the distance into inches. When finding a new distance, it would show the previous distance on the top line and the new distance on the bottom line. If the distance was further than 330 centimeters or closer than 3 centimeters, an error message would display on the screen. So first, let's start off with the materials I need to build an ultrasonic distance gun. So we need the Arduino Uno board, we need the breadboard, and we also need a 9-volt power supply. Next, we would need a 16 character by 2 character LCD to display the distance got by the gun. And we would need an HC-SO4 ultrasonic sensor to get the distance. We will also need 2 4-pin push buttons, one to get the distance and the other to display it in inches, along with 2 10K resistors for those push buttons. We also need a 10K potentiometer along with the 220 ohm resistor for the LCD. I also chose to use 8 LEDs, 4 blue ones and 4 red ones. The closer the object is, the brighter the LEDs would light up. And the LEDs would use 2 10 ohm resistors for each 4 pairs of LEDs. Lastly, we will need 16 male to male wires, 35 male to female wires, along with 2 female to female wires.
Before buying everything separately, I looked for a kit that came with everything I needed, and luckily I found this one on Amazon for $36 at the time. The Arduino kit didn't come with many male to female wires, so I bought this pack that came with 40 of each type wire for the price of $14. So why did I choose Amazon? I chose the convenience of buying from Amazon instead of other websites because I wanted a guarantee that all my parts would come on time, and if I needed to make any returns, I would be able to. This is my schematic diagram. I don't often use schematic diagrams because they aren't really that useful. They're usually hard to read. Connecting the components in real life.
After I decided what I was going to build, I did some research on the parts I would need and got to work. My first goal was to get the distance and display it on the LCD. I first needed to know how to connect the LCD and ultrasonic sensor to the breadboard and the Arduino Uno, so I figured that out. Next, I needed to know how to write the code to get the distance from the sensor. It was a bit complicated at first, but this website helped me out to figure that out. So first it told me what pin was the input and which one was the output, and that was helpful. And the website also helped me understand how the distance was actually being got. After I coded in how to get the distance from the ultrasonic sensor, I needed to print that onto the LCD, which was actually pretty simple. First, we had to import the liquid crystal library, and then also connect it to the Arduino board and tell which port does what. And the print statements were pretty simple, it was just LCD print all the time. First, I wanted to add the push button so the ultrasonic sensor only gets a distance when the button is being pushed. So I had to research how to connect the pins and set that up. Adding the push buttons wasn't hard, and so wasn't setting it up. The if statements were pretty simple and similar to Python. I also wrote the code for if the distance is too far for the ultrasonic sensor to measure, then an error would appear on the LCD. Now I wanted to add another button that if it was pressed, it would show the distance in inches. Next, I wanted to make it so when a new distance was gotten, it would show the previous distance on the top line. I found this a little bit hard at first, but after I figured it out, it was as simple as just adding a delay after the button was pushed. Lastly, I wanted to add LEDs, so the closer the object was to the sensor, the brighter the LEDs would light up. I already knew how to connect the LEDs to the breadboard and Arduino, so that wasn't much of a problem. So today I decided to buy the Arduino kit. The Arduino kit had finally arrived, and it was time for me to finish the LED setup. Now that I was done the LED setup, everything looked done and it was time to just check if everything worked properly. First I had to upload the code onto the Arduino board. I didn't have much of a problem with that because the port automatically detected the board. So the first problem I encountered was that I did not have enough female to male connectors. Also, the push buttons did not want to connect to the female connectors and only wanted to connect to the breadboard. And also I couldn't tell which side of the potentiometer was the power and the ground. So how I solved these problems were that first of all I had to buy more female to male connectors, and for the push buttons I figured out a way to make it connect. And for the potentiometer I found some online pictures that helped me decide which way to put it in. Now that the cables had arrived, it was time for me to continue working. I tried my best to color coordinate, and I connected everything similarly to the pictorial diagram. So I ran into one problem, which was I accidentally put the resistor on the right in the wrong hole, so I had to fix that. And I put the potentiometer in the right way on my first try, but I forgot to turn the knob, but once I turned the knob, the LCD displayed. I know how I want my final project to look, so I want to put it in this cardboard cutout first to see if all the wires easily bend and fit. While putting everything in the cardboard cutout, I found a bunch of loose wires in the power rails, so I glue gunned all those. The blue LEDs didn't want to work for some reason, so I had to use yellow ones instead. Now that everything was in the cardboard, I was looking for some thin wooden material to go over the cardboard. The closest thing I could find to a thin wooden material was popsicle sticks from Dollarama, since Home Depot was closed at the time. I covered the cardboard with it and I think I'm done. So first I want to connect the Arduino board to the breadboard. So I would do that by connecting one wire to the 5 volts and one wire to the ground, and then taking the wire connected to the 5 volt and putting it in the plus and the other one in the minus. So next I decided to connect the potentiometer to the breadboard, and I pushed it down as tightly as I could so it doesn't move. And the red wire goes on the left side and the black one goes on the right side. And this wire right here, that would be connected to the LCD. So you want to connect the female to male wires to the LCD. All the pins on the back except D0, D1, D2, and D3. So we're mostly just following the pictorial diagram. The wires that go into the power and negative go in there, and the rest are just connected to the breadboard that will be connected to the Arduino board. Also, to connect this red wire to this resistor and this white wire to the potentiometer. So next I just connected the remaining wires of the LCD to the breadboard. So I next went ahead and connected the ultrasonic sensor to the breadboard, which was connecting the red wire to the positive and the black to the negative, and then the trig pin and the echo pin wire to the breadboard. And then I took those two wires and connected them to the Arduino board. So next I chose to connect the LEDs to the breadboard, and then the wire that connects all the LEDs together to the Arduino board. All I have left were the push buttons, and I basically just taped the wires into the pins so they won't get out, and connected it to the Arduino board and also the breadboard. And I'm thinking about glue gunning these pieces, the two resistors and those two red wires, because they're feeling pretty loose. So all that's left now is to test it and see if it works, and then we can start covering it up. So this is an Amazon box I used to make the mold for the parts to go in. So this is where the breadboard would go, and this is where the Arduino board would go, and these two holes, and this hole is made for the push buttons to go, and these holes on top are meant for the LED. This open hole is where this would go for the ultrasonic sensor, and this is where the LCD would be. So it's still open, but if I close it real quick, it should look something like this when closed. With that there. Yeah. So this is how my project looks inside the case. So this is how my final project looks with the popsicle sticks on the cardboard. I also had to end up holding my laptop because while filming the battery ended up dying. Okay, now let's get an error. Let's go super back. Oh jeez, I'm so sorry. Can you see the gun? Oh, okay. So now it's just, oh shoot, it's still not far away enough. Don't worry, it's okay. That should be far away enough, okay? Oh yeah, see, error, we got error.